Okay, so we're going to talk about the converse of Pythagorean theorem. So Pythagorean theorem says if a triangle is right, then if you square the legs and add them together, that's going to be equal to the square of the hypotenuse. So for these guys here, what I'm going to do is we're just going to kind of look at what happens in your other triangles as far as angles go. When you do Pythagorean theorem on those. So you have only three other classifications. You have right, acute, and obtuse. An equiangular triangle is acute because they have all 60-degree angles. So this is going to be, so I'm going to do Pythagorean theorem here. I'm going to say 10 squared and then 5 squared plus 5 radical 3 squared. So 10 squared is 100. 5 squared is 25. I'm going to actually kind of leave a little blank here. Plus 5 squared is 25, and radical 3 squared is 3. So this is 100, 25 plus 75. Well, 100 is equal to 100. So this has to be a right triangle because Pythagorean theorem only works on right triangles. We now look at our acute triangle. We determine what the longest side is. I actually convert my 3, I convert that into a radical. So all I do is take my whole number and square it, if I didn't have a calculator, just to make sure that I have them. And sure enough, 15 is the longest side. So I'm going to say radical 15 is what to 3 squared plus radical 7 squared. So radical 15 squared. Radical 15 squared is just 15. 3 squared is 9. 7 squared is 7. 15, well, 9 plus 7 is 16. Well, they're not equal, so I know it's definitely not a right triangle. I told you it wasn't a right triangle. 15 is actually less than 16. And so this is an acute triangle, and so that's what I want you guys to think about. Is this an acute triangle? If I square the longest side, it's actually less than the sum of the other two sides, it being acute. And of course, our last one, this would be, if I'm comparing this would be radical 49. This would be radical 225. This one right here, well, this would be a radical 25 times a radical 5, so this would be radical 125 if I were to convert this back into a radical. So I just square my whole number and then multiply it by whatever is left in. Don't need to know that, just some more algebra skills. So I would set this up, it would be 15 squared is what to 7 squared plus 5 radical 5 squared. So we have 225, 7 squared is 49, this is 5. And then just be careful with these, square each part. 5 squared is 25, and radical 5 squared is 5. So we have 225, 49 plus 125, and 49 plus 125 is 174. And so 225 is greater than 174, and that happened to be for our obtuse triangle. That actually happens every single time. You can use Pythagorean theorem to determine what type of triangle. So if it's a right triangle, then c squared is equal to a squared plus b squared. It's an acute triangle if c squared is less than if c squared is less than a squared plus b squared, then ABC is acute. And if c squared is greater than a squared plus b squared, then ABC is obtuse. So one of the first things, and we're going to go back to, it was unit 3. Yep, unit 3. First off, when I'm asking you these questions, I'm going to ask you what type of triangle it is, but first you need to tell me, can it even represent a triangle? So you have a 3, 4, 5. I actually know already, you guys know already, that's a Pythagorean triple. I know that that works in Pythagorean theorem, so this would be a triangle, but let's just make sure, this is what I mean. I know that my third side, 3, would have to be greater than the difference, 5 minus 4, and less than the sum, which is 5 plus 4 is 3 between 1 and 9. So it is a triangle. And then I want to see if it's a right triangle. So of course my longest side is going to be C. So is 5 squared is what to 3 squared plus 4 squared. So 25, this is 9 plus 16, 25, and then we have 25. They are equal to each other, so this has to be a right triangle. Okay, we go to the second one. And I actually don't like, first thing you do is determine if it is a triangle. So we have is 10 less than 5 plus 5 and greater than 5 minus 5. So is 10 between 0 and 10? No, this is not a triangle. The next one, and I'm actually going to fix this in post. So the next one, I would set this up. This would be my C. So is 12 squared is what to 10 squared plus 10 squared? 12 squared is 144. This is 100 plus 100. 144. 144 is what to 200, is what to 200. Well, 144 is less than, so this would have to be acute. Again, I want to emphasize the fact that if it is not a triangle, you do not have to solve it because it's not a triangle. So I'm going to change this last one a little bit, only because, oh, I didn't even check to see if it was a triangle, only because I don't like the answer. So, so for this one, I'm actually going to cross these out, and yours will have something different. I'm going to have 12, 6, radical 2, and 7. Okay. If you go through, the third side is greater than the difference, less than the sum. These are ones that I definitely would have you use a calculator on, just to determine. So this, yes, was a triangle. This one is 10 less than 22 and greater than 2. That checked out. Okay. And then for this one right here, you would say is 7 less than 12 plus 6 radical 2, which that's for sure, because that's more than 6. And is it greater than 12 minus 6 radical 2? Well, in order, you'd have to subtract more than, for it to be, for that to be false, you would have to subtract more than 7. So again, we have your 12, 6 radical 2, and 7. My longest side is my 12. So I'm going to do 12 squared is what to 6 radical 2 squared plus 7 squared, 144, and then we have 36 times 2 plus 49. We have 144, 72 plus 49. And that's going to be 121. And so 144 is greater than 121. So this must be obtuse for the new example. All right, number 5, last one, kind of an interesting one. ABC is an acute triangle. Two of its sides measure 13 and 7. What is the range of possible values for its third side? So, one of the first things that we can determine is using, I know that if it's an acute triangle, two of the sides measure 13 and 7, I know that my third side has to be greater than the difference and less than the sum. So my third side, one of the first things I know is it's got to be less than 13 plus 7 and greater than 13 minus 7. Okay, so 13 minus 7 is 6. And it has to be less than 20. Okay. So the other thing that I know that actually might be a little bit helpful, I also know if it's an acute triangle, then that third side, if I square it, has to be less than the sum of the other two sides. So that's my first thing. This is from your unit 3, and then this is this present unit. This is today's lesson. So x squared has to be less than 169, or the square root, or 169 plus 49. So x squared has to be less than 218. So my other side has to be less than the square root of 218, which is, and we're going to use an approximation just to kind of give you an idea, is approximately 14.7. So, which is about, so x has to be less than 14.7. So here I have x is less than 20, but here I have x is less than 14.7. And so if it's greater than 14.7, it's actually no longer to be an acute triangle, it'd be an obtuse triangle or a right triangle. So I know that my third side has to be, and this is going to be the other end of it, my third side has to be less than, or greater than 6 and less than 14.7.